Let's take a look at this last scenario about the French club. Instead of having 4 different officers, Monsieur Dubois could have decided that the French club would have an executive committee consisting of 4 students. These 4 students would share the responsibilities of leading the club. How many 4-person committees are possible? So this problem differs from number 2 in that we don't have different specific roles for the 4 people that are leading the club. They're just going to work collaboratively. So what this means is that the selection order of the students does not matter. Even if Monsieur Dubois still puts all the kids' names in a hat and pulls them out one at a time, as he's pulling the names out, the order in which those names are read, right, those 4 names he pulls out, doesn't matter because we're no longer assigning those 4 students to specific offices or roles. So what this is suggesting is that we're just picking a group. We're picking a smaller group from the 10. We're picking a group of 4 from the 10, and the order of selection really doesn't matter. So that indicates for us that this is a mathematical combination. So to use the combination notation, use a capital C for combination. To the left of the C, we still put the number of people we're picking from, so our pool of students, there are 10. The C stands for combine, also stands for choose, so usually that's how we'll say it. 10, choose. And then over here on the other side of the C, we're going to go ahead and put the number of people we're actually choosing. So we're choosing 4 to make up our committee. So the way you could say this is 10, choose 4. Of 10 people, we're just picking 4 to form the committee. You could go to your calculator, type in 10, go to math, PRB, option 3 this time, type in 4, and we can see our calculator right away tells us that there are 210 possible committees. You can see we get an answer a lot smaller than the answer that we got for number 2. Number 2 was considering all the ways to arrange the 4 people that we are selecting. In number 3, we don't care about the arrangement of the people. Let me make some more sense of this using that fill-in-the-blank strategy. We do have 4 sort of slots on the committee. We have 10 students who might be, pulled out of the hat first, right? There's 10 options, and then 9, 8, and then 7. Just like in number 2, we know that multiplies out to be 5,040. Now, this number is including all the different ways to arrange the 4 people that are selected. So as an example, let's pretend we pick out of the hat, the names of the kids that are picked out of the hat are Anna, Ben, Carl, and David. Okay, so that would be committee A, B, C, D. Now, if we were to pick those same 4 names out of the hat in a different order, maybe A, C, B, D, the selection order in this situation doesn't make these 2 separate or unique committees. Committee A, B, C, D has the same grouping of students as committee A, C, B, D. There are lots of ways we could arrange these same 4 letters or same 4 students on the committee. Specifically, the number of ways to arrange 4 objects is 4 factorial, right? If you had 4 students and you wanted to arrange them, you would do 4 times 3 times 2 times 1. So there are 4 factorial different arrangements of the same grouping of kids. And those aren't different committees. Again, these 2 committees are not different. So we have to get rid of all those kind of repeated committees that are really just the arrangements of the same committee. So we have to take this 5,040 and divide it out by 4 factorial. Again, we're taking that 10 times 9 times 8 times 7 and dividing it out by 4 factorial. And that's to get rid of all of the ways to arrange the 4 people that we're picking. Again, these are different arrangements, do not make different committees. So we have to get rid of those arrangements. And there are 4 factorial. That's the number of ways to arrange 4 objects. Let's look at the factorial notation when we go from the combination notation into factorial notation. On the top, we put 10 factorial. That's the number of ways to arrange all 10 people. Remember, we're not arranging all 10 of them. We only have room for 4 of them. That's why we divide by the 6 factorial. That's 10 minus 4. Divide by 6 factorial because we only have 4 slots. And then additionally, we have to divide by 4 factorial to get rid of all those repeated ways to arrange the students that actually form the same committee. So our answer is 210. You could use the combination notation in your calculator to get the 210. You could think about filling in slots and then remembering that you have to get rid of all those repeated arrangements and do some division. Or you also could use the factorial notation to arrive at that answer of 210 committees.